The National Electrical Code, or NEC, doesn't explicitly prohibit 480 volts corner-grounded systems. However, it's important to recognize that these systems aren't as prevalent as 240 volts corner-grounded systems. One reason 480 volts corner-grounded systems might be permissible in certain jurisdictions is that they establish a pathway for ground fault current to return to its source. In a delta system, the absence of a neutral conductor means that a ground fault on a single phase would cause the voltage in the remaining two phases to escalate to line voltage. Corner grounding offers a route for the ground fault current to return to the source, thus safeguarding against overvoltages. 240 volts corner grounded systems find more common use in residential and light commercial settings. Conversely, 480 volts systems are typically employed in industrial and commercial applications where greater power demands exist. Even though 480 volts corner grounded systems might be legal in specific regions, they do introduce certain safety considerations. One such concern is that a ground fault on one phase has the potential to elevate the voltage on the other two phases to 480 volts, presenting a hazardous scenario. Furthermore, a ground fault on a single phase could disrupt the system's balance, leading to additional complications. If a 480 volts corner-grounded system is present, it's imperative to implement precautions that ensure safety. These measures could encompass, firstly, the installation of ground fault circuit interrupters, or GFCIs, on all circuits, secondly, the utilization of equipment rated for 480 volts, and thirdly, regular inspections of the system conducted by a qualified electrician. In summary, while 480 volts corner-grounded systems may be legal in some areas, they aren't as widespread as 240 volts corner-grounded systems and involve certain safety concerns. When dealing with a 480 volts corner-grounded system, prioritizing safety measures is crucial. Understanding the nuances of corner-grounded delta systems, particularly those operating at 480 volts, requires a comprehensive grasp of electrical engineering principles and safety regulations. Let's delve deeper into the technical aspects and considerations surrounding these systems. A 480 volts corner-grounded delta system is a type of three-phase electrical distribution system where one of the phase conductors is intentionally connected to ground. This grounding configuration differs from other common systems like Y systems, where the neutral point is grounded, or high-like delta systems, where the midpoint of one phase is grounded. The primary purpose of corner grounding is to provide a reference point for voltage and to limit the potential voltage rise during ground fault conditions. The legality of using 480 volts corner grounded systems varies depending on local electrical codes and regulations. While the NEC doesn't explicitly prohibit them, local jurisdictions may have specific requirements or restrictions. It's essential to consult with local electrical inspectors and authorities to ensure compliance with all applicable codes and standards. One of the main reasons why 480 volts corner-grounded systems are permitted in some areas is their ability to provide a path for ground fault current to return to the source. In a delta system, there is no neutral conductor, so a ground fault on one phase would cause the voltage in the other two phases to rise to the line-to-line voltage, which is 480 volts in this case. Corner grounding provides a low impedance path for the fault current to flow back to the source, which helps to quickly clear the fault and prevent overvoltages. This is crucial for protecting equipment and personnel from electrical hazards. 240 volts corner-grounded systems are more commonly used in residential and light commercial applications because they offer a balance between safety and cost-effectiveness. At lower voltage levels, the risk of electrical shock and arc flash is reduced, making them suitable for environments where untrained personnel may be present. 480 volt systems, on the other hand, are typically used in industrial and commercial applications where high power levels are required. These systems are more efficient for transmitting and distributing large amounts of power, but they also pose a greater risk of electrical hazards. Therefore, extra precautions must be taken to ensure safety when working with 480 volts corner-grounded systems. One of the primary safety concerns associated with 480 volts corner-grounded systems is the potential for high voltage exposure during ground fault conditions. As mentioned earlier, a ground fault on one phase can cause the voltage on the other two phases to rise to 480 volts. This can create a dangerous situation for anyone who comes into contact with the faulty equipment or wiring. Additionally, a ground fault on one phase can cause the system to become unbalanced, which can lead to overheating of transformers and other equipment. To mitigate these safety concerns, it's essential to implement several safety measures. Firstly, install ground fault circuit interrupters or GFCIs on all circuits. GFCIs are designed to detect even small amounts of ground fault current and quickly interrupt the circuit, preventing electrical shock and arc flash hazards. Secondly, use equipment that is rated for 480 volts. This includes wiring, connectors, switches, and other electrical components. Using equipment that is not properly rated for the voltage can lead to insulation breakdown, overheating, and other failures. Thirdly, have the system inspected regularly by a qualified electrician. Regular inspections can help to identify potential problems before they become safety hazards. An electrician can check for loose connections, damaged wiring, and other issues that could lead to ground faults or other electrical problems. In addition to these safety measures, it's also important to follow safe work practices when working with 480 volts corner-grounded systems. This includes wearing appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. It also includes de-energizing equipment before working on it and using lockout/tagout procedures to prevent accidental energization. Furthermore, it's important to be aware of the potential hazards associated with arc flash. Arc flash is a dangerous phenomenon that can occur when a high-voltage electrical arc forms between two conductors. Arc flash can produce intense heat, pressure, and light, which can cause severe burns, blindness, and even death. To protect against arc flash hazards, it's essential to wear arc-rated PPE and follow safe work practices. In conclusion, while 480 volts corner-grounded systems may be legal in some jurisdictions, they are not as common as 240 volts corner-grounded systems and pose some safety concerns. If you have a 480 volts corner-grounded system, it's important to take precautions to ensure safety. These precautions may include installing GFCIs on all circuits, using equipment that is rated for 480 volts, and having the system inspected regularly by a qualified electrician. Additionally, it's important to follow safe work practices when working with 480 volts corner-grounded systems to protect against electrical shock, arc flash, and other hazards. Understanding the specific requirements and regulations in your local jurisdiction is crucial for ensuring the safe and compliant operation of any electrical system. Remember, electrical safety is paramount, and it's always best to consult with qualified professionals to ensure that all safety measures are in place and properly maintained. Now, let's explore some additional technical aspects of 480 volts corner-grounded delta systems. Understanding the voltage relationships within the system is crucial for troubleshooting and maintenance. In a corner-grounded delta system, the voltage between any two ungrounded phases is 480 volts, which is the line-to-line voltage. The voltage between the grounded phase and either of the ungrounded phases is also 480 volts. This is because the grounded phase is directly connected to ground, and the voltage between any phase and ground is considered the phase-to-ground voltage. One important consideration when working with corner-grounded delta systems is the potential for circulating currents. Circulating currents can occur when there are slight imbalances in the system, such as differences in impedance between the phases. These circulating currents can flow through the grounded phase and back to the source, causing increased losses and potential overheating of equipment. To minimize circulating currents, it's important to ensure that the system is properly balanced and that all connections are tight and clean. Another important aspect of corner-grounded delta systems is the protection of transformers. Transformers are used to step down the voltage from the distribution level to the utilization level. In a corner-grounded delta system, the transformers must be specifically designed to handle the voltage stresses associated with the grounding configuration. This typically involves using transformers with reinforced insulation and special grounding connections. It's also important to protect the transformers from overcurrents and overvoltages. Overcurrent protection can be provided by fuses or circuit breakers, while overvoltage protection can be provided by surge arresters. Surge arresters are devices that are designed to divert high-voltage surges to ground, protecting the transformers from damage. Furthermore, the selection of appropriate overcurrent protection devices is crucial for ensuring the safety and reliability of the system. The overcurrent protection devices must be sized to protect the conductors and equipment from overloads and short circuits. It's also important to consider the coordination of overcurrent protection devices to ensure that the fault is cleared by the nearest device to the fault. This helps to minimize the extent of the outage and prevent damage to other equipment. In addition to the technical aspects, it's also important to consider the operational aspects of 480 volts corner-grounded delta systems. One important consideration is the maintenance of the grounding system. The grounding system must be properly maintained to ensure that it provides a low impedance path for ground fault current to return to the source. This includes regularly inspecting the grounding conductors and connections to ensure that they are tight and clean. It also includes testing the grounding system to verify that it is functioning properly. Another important operational aspect is the training of personnel. Personnel who work on 480 volts corner-grounded delta systems must be properly trained in the safe work practices and procedures. This includes training on the hazards associated with electrical shock and arc flash, as well as training on the proper use of PPE and test equipment. Proper training is essential for preventing accidents and ensuring the safety of personnel. Finally, it's important to document all aspects of the 480 volts corner-grounded delta system. This includes documenting the system configuration, the grounding system design, the overcurrent protection scheme, and the maintenance procedures. Proper documentation is essential for troubleshooting problems and ensuring that the system is properly maintained over time. In summary, 480 volts corner-grounded delta systems are complex electrical systems that require careful consideration of both technical and operational aspects. By understanding the voltage relationships, the potential for circulating currents, the protection of transformers, the selection of overcurrent protection devices, the maintenance of the grounding system, the training of personnel, and the documentation of the system, it's possible to ensure the safe and reliable operation of these systems. Remember, electrical safety is paramount, and it's always best to consult with qualified professionals to ensure that all safety measures are in place and properly maintained. Let's further examine some practical considerations and best practices when dealing with 480 volts corner-grounded delta systems in real-world scenarios. First, consider the impact of load balancing on system performance. In any three-phase system, including corner-grounded delta systems, it's crucial to distribute the load as evenly as possible across all three phases. Uneven loading can lead to voltage imbalances, increased losses, and potential overheating of equipment. To achieve proper load balancing, it's important to carefully plan the distribution of loads and to regularly monitor the current on each phase. If significant imbalances are detected, adjustments should be made to redistribute the load more evenly. Secondly, examine the selection and application of surge protection devices. Surge protection devices, or SPDs, are essential for protecting sensitive electronic equipment from voltage surges caused by lightning strikes, switching transients, and other disturbances. In a corner-grounded delta system, it's important to select SPD that are specifically designed for this type of system. The SPD should be installed at the service entrance and at other critical locations throughout the system to provide comprehensive surge protection. Thirdly, consider the use of harmonic filters to mitigate harmonic distortion. Harmonic distortion is a phenomenon that can occur when nonlinear loads, such as variable frequency drives, or VFDs, and electronic ballasts, draw non-sinusoidal currents from the power system. These non-sinusoidal currents can cause voltage distortion and can lead to overheating of transformers and other equipment. To mitigate harmonic distortion, harmonic filters can be installed to reduce the amplitude of the harmonic currents. Fourthly, address the importance of proper grounding electrode system design. The grounding electrode system is a critical component of any electrical system, including corner-grounded delta systems. The grounding electrode system provides a low impedance path for ground fault current to return to the source, which helps to quickly clear faults and prevent overvoltages. The grounding electrode system should be designed in accordance with the NEC and should include a combination of grounding electrodes such as ground rods, ground plates, and underground metallic water pipes. Fifthly, emphasize the need for regular insulation testing of conductors and equipment. Insulation testing is an important maintenance procedure that can help to identify potential insulation failures before they lead to equipment breakdowns or safety hazards. Insulation testing should be performed regularly on all conductors and equipment in the 480 volts corner grounded delta system, including transformers, switchgear, and motors. The insulation resistance values should be compared to the manufacturer's specifications to determine if the insulation is in good condition. Sixthly, discuss the implications of using 480 volts corner grounded delta systems in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. In these locations, it's important to use equipment that is specifically designed and certified for use in hazardous locations. This equipment is designed to prevent ignition of the flammable substances and to protect personnel from electrical hazards. If a 480 volts corner grounded delta system is used in a hazardous location, extra precautions must be taken to ensure that all equipment is properly rated and installed. Seventhly, highlight the significance of arc flash hazard analysis and mitigation. Arc flash hazard analysis is a process that is used to determine the potential arc flash hazards in an electrical system. The analysis involves calculating the incident energy that could be released during an arc flash event and determining the appropriate PPE that is required to protect personnel. Once the arc flash hazards have been identified, mitigation measures can be implemented to reduce the risk of arc flash. These measures may include installing arc-resistant switchgear, using remote racking devices, and implementing lockout/tag-up procedures. Eighthly, underline the necessity of comprehensive documentation and record keeping. Comprehensive documentation and record keeping are essential for the safe and reliable operation of any electrical system. The documentation should include detailed drawings of the system, including the location of all equipment and conductors. It should also include records of all maintenance activities, including insulation testing, grounding system inspections, and equipment repairs. Proper documentation and record keeping can help to troubleshoot problems and ensure that the system is properly maintained over time. In conclusion, 480 volts corner grounded delta systems require careful attention to detail and a thorough understanding of electrical safety principles. By following these practical considerations and best practices, it's possible to ensure the safe and reliable operation of these systems and to protect personnel from electrical hazards.